Okay, so we've talked quite a bit now about quadratics, and it's time to switch gears a little bit to absolute value equations. And let me start with this very basic equation. The absolute value of x is equal to 3. Okay. So let me refresh your memory and illustrate a little bit what this means. Absolute value means distance from 0. Okay, so let's write that down here. So absolute value here really means distance from 0, okay, on a number line. So this is saying, look, I got this number line, I have the point 0 here, and I have a number that has a distance from 0 of 3. Okay, so whatever this number is, it's got a distance from 0 of 3. But keep in mind that there's another number on the other side of 0 that also has a distance from 0 of 3. Okay? And if we solve this, of course, the answer is x equals 3, because the absolute value of 3 is 3, and x is equal to negative 3, because the absolute value of negative 3 is also 3. And so that's the main idea behind the absolute value equations, is that there may be two solutions. And I say maybe because sometimes there may only be one, sometimes there might not be any. So our next example here has the absolute value of quantity 2x plus 1 equals 5. And when we're solving for x, we're trying to get x by itself. And so normally, if we didn't have the absolute value symbol, we could just subtract 1 from both sides and proceed from there. But because we have the absolute value symbol, we have to treat it a little bit differently. So keep in mind the previous example that there was two solutions when we take away the absolute value symbol. So the same thing is true here. There are two solutions or two equations when we take away the absolute value symbol. The first one is 2x plus 1 equals 5. And the second one is 2x plus 1 equals negative 5. Just like we had up here, when we take away the absolute value symbol, there are two equations, one with a positive value and one with a negative value. And so now we just need to solve these two equations. Subtract 1 from both sides, you get 2x equals 4, and divide both sides by 2, you get x equals 2. Same thing here. Subtract 1 from both sides, you get 2x equals negative 6. And divide both sides by 2, you get x equals negative 3. And both of those are good answers. And it's very important that we check our solutions. I always get nervous when I see a negative answer and there's an absolute value involved. So let's check, and in fact, let's check both of these. Is the absolute value of 2 times 2 plus 1 really equal to 5? Well, 2 times 2 is 4, plus 1, that's 5. The absolute value of 5 is in fact 5. So that's good. Put a check mark there. Okay. Let's check the other one. Is the absolute value of 2 times negative 3 plus 1 really equal to 5? Well, 2 times negative 3 is negative 6, plus 1 is negative 5. The absolute value of negative 5, in fact, is 5. So that's good. So we checked and we verified that this works. Okay. And again, you should check for all your problems, but it's especially important to check for absolute value equations, because sometimes you might solve an equation and the answer might not work in the original problem. So I have example 8 here in front of me, and two problems. Absolute value of 3x minus 5 equals x plus 3. So this is a little bit different because we have a variable on the right side, whereas before we may have just gotten a number. And I'm going to leave you to do part B on your own, and just remember to check your answers when you do part B. Okay? So applying what we know from before, we can take away the absolute value symbol, but two equations are formed. Okay, so I'll write this in the left side here just so that we remember. So when removing absolute value symbols, two equations are needed. And so the first equation is 3x minus 5 equals x plus 3. And let's solve that right now. You can subtract x from both sides and you get 2x minus 5 equals 3. 2x, add 5 to both sides, that's 8, and x equals 4. So that's one solution. And the other solution is 3x minus 5 equals, now you got to be careful, you want to put a negative here on the right side, but we have to negate the entire quantity. So you have to put x plus 3 in parentheses and a negative sign in front of that, because this is saying that this expression here could be equal to the negative of whatever's on the right side. Sometimes it may be just a number, sometimes it may be a number and a variable. So you got to be very careful on how we treat that. So this is 3x minus 5 equals negative x minus 3. This gives you 4x equals, I'll show all of my steps here, 4x minus 5 equals negative 3. 4x equals 2, because I'm adding 5 to both sides, and then x equals 1/2. Okay? And like I said before, it's important that we check our answers to make sure that they actually work. So let's check. Is the absolute value of 3 times 4 minus 5 really equal to 3, oh, I'm sorry, x is 4 here, plus 3. Well, this is 3 times 4 is 12, minus 5 is 7, and that really is equal to 4 plus 3 here, that really is equal to 7. So that's good. Now let's check the one with a fraction. Is the absolute value of 3 times 1/2 minus 5 equal to 1/2 plus 3? This is 3/2 minus 5, so that is going to give me negative 3.5. Okay. And that is in fact equal to 1/2 plus 3, because that's also 3.5. So that's good, that's working. So all of our examples have worked so far. And I will let you work on part B on your own, and we will review this in class. Just make sure once more that you check your answers once you are done. And one final note is that we can definitely solve all of these equations using a graph. Okay, so, using one of the graphing methods that I showed you earlier in the video, in some other video. But I wanted to show you the algebraic way of doing this.